All right, team. This is going to be the model of a Riemann sum or table problem. First of all, before we get started on this, please write your name. Also, take a second to identify the question type. The reason these are called table problems is they're going to give you a table and ask you to make conclusions about it. So this is going to be a table problem. You could also read into part C and say, oh, it's going to be a Riemann sum. So you get your brain working that way. Also, take a second to remind yourself of the goal here. 5 out of 9 is going to give you a 4 on the AP test, and you only need to get 6 out of 9 to get a 5. So when you're getting stressed, just remind yourself, hey, I only need to prioritize the 4 or 5 points on this that I know how to do. And you can use that to your advantage. Shout out to the people on the test who skipped part D because they knew that they already had their 5 or 6 points that they needed. All right, let's get started. A is asking us to estimate the value of h prime. H prime of 4. Then we're going to have to interpret. And it also mentions use the correct units. Okay? So here's how we are going to do all of that. First, let's talk about h prime of 4. In the table, I see time in years, and h of t is meters per year. This problem's about a tree that's growing. But I don't see 4. They do give me 3 and 5. So what I think about this is I think, oh, a derivative, I could say this is the slope, not the stop, the slope at t equals 4. And then I remember, hey, finding slope is actually really easy. I'm just going to do y2 minus y1 over x2 minus x1. And I'm going to use these points because 4 would be right in the middle of 3 and 5 for t. So let's plug this in. On top, I would have my h of t, so it would be 6 minus 2. Over 5 minus 3. And actually, this is the first point right here. If you show what's called the difference quotient, you get the point. They call the difference quotient because the difference means subtraction, and the quotient means division. And this, of course, simplifies to 2. Now, next thing we're going to talk about is the units. Units. Okay. So up here it gives me meters per year. Did I make this h prime of t? That should just be h of t. Sorry, guys. If I had a unit of meters and I took the derivative, so this would be the derivative with respect to time, d dt, I would get meters per year. And that's what you see right here. If I took the derivative again, the derivative with respect to time, d dt, I would get meters per year squared. Now, if I wanted to go up, I would just use an integral. So you might have to take the integral of meters per year squared and wind up with meters per year. So now I know that my units are 2 meters per year squared. Now, a pro tip on the AP exam, if they're ever asking for units and you're not sure, you can just guess on the number. Like if I had put 100, which is totally wrong, meters per year squared, which is right, I still would be eligible for the second point, even if I messed up this. Pro tip. Now let's finish this off by interpreting. Okay, so we have to think about what's happening here. The tree is growing at a rate, meters per year. We found h prime of 4, which is 2 meters per year squared. And we have to interpret that. So I'm going to write h prime of 4 is the rate at which the height of the tree is changing in meters per year squared when time equals 4. And this would be my second point on this problem. 2 points. All right, this is for part B. Part B is asking, explain why there must be a time, t, on 2 to 3 such that h prime of t equals 0.5. Now, this is called the mean value theorem. You see it abbreviated as MVT. Mean value theorem. Mean value theorem says if a function is continuous and differentiable, then on the interval, this is funny, they write it as A is less than or equal to C, which is less than or equal to B. And what they're saying is, on the interval from A to B, there is a third point. On the interval A is less than C, which is less than B, there is a value that they call C, such that the average rate of change is equal to f prime of C. It's called the mean value theorem. On this problem, it's asking between 2 and 3. So I'm going to use these 2 points right here, 2 and 3. First thing I'm going to do is find the average rate of change. Okay, so the average rate of change is going to be, on top, I'm going to have 2 minus 1.5 and 3 minus 2. So it'll be, 2 minus 1.5 divided by 3 minus 2. Now, this is your first point. You have to have the difference quotient like we had in the problem before. And so you would get 0.5 over 1, and that would just equal 0.5. Okay? Now, this is what the question's asking. It's saying, hey, the derivative of h must equal 0.5. And here's why. Let's say, I'm going to draw a quick sketch of this. On the bottom, we had 2 years and 3 years. This is our A and our B. And when the tree was 2 years old, it was growing at 1.5 meters per year. When the tree was 3 years old, it was growing at 2 meters. And this, if I drew a line between here, I would get a slope of 0.5. Now, the mean value theorem says no matter what, no matter how I draw my function, you usually see something kind of curvy, there is a point where the slope of our function is equal to the average value. I could draw it in red like that. I could draw it in green like this. And I would still have a point, yeah, somewhere over here, maybe over there, where these are parallel. Okay. So after I've proved the mean value theorem, I have to do the justification. Now this is kind of a handful, so bear with me. Okay. Because h of t is continuous and differentiable, okay, you have to use those words. You have to say continuous. You have to say differentiable. On the interval, 2 is less than t, which is less than 3. I'm just getting this from the problem. Okay. And what the AP test, you have to have this. You have to connect the interval to the mean value theorem. So here's how you do this. You say there is a point C, and again 2 is less than or equal to C, which is less than or equal to 3. I'm just substituting C for T because we have to connect it to the mean value theorem. And you would say such that h prime of C equals 0.5. That's what we proved up here. And last thing you have to do is you just have to say, I'm using the mean value theorem. So people say by MVT for the mean value theorem. So make sure you include by MVT. It's got to be in there. All right, team. Now we're doing part C, which says to use a left Riemann sum with 4 subintervals to approximate the integral from 2 to 10 of h of t dt, h of t dt. And then also it's asking for context. Oops, there's an N there, context. Okay, left Riemann sum. To do this, I'm going to draw a quick sketch. You don't have to. Lily last year always drew these, and she was great at Riemann sum, so you're welcome to if you would like. So I've got time and I've got h of t, and again, this is the meters per year, and I see that my function is increasing, and it's making these little points all the way up to here. Now, this is all I know about my function. Before people learn calculus, they learn to do these approximations using Riemann sums. So this is a left Riemann sum. That means when I'm looking at an interval, and by the way, it tells us to start at 2. When I'm looking at an interval, I'm going to use the left side. So like this is the left side, this is the right side, and I know I'm going to draw my box like this. Now we've also learned that an integral can mean area. So I'm going to have to find the area of this. I see this is 1 space, and this is 1.5. Gosh, I did not draw this to scale, did I? So when we go to do our answer, I'll say the integral of h of t dt from 2 to 10. I'm going to do the area of all these little boxes. So the first one, I'm going to write 1.5 times 1. All right, 1.5 times 1. Another way to do that is to look at your intervals up here. I'm going to look at 2 and 3. I see that this part's on the left. So I'll know, oh, my first one is 1.5 from 2 to 3. Doing this from the table, I can say, okay, the height of my next one is going to be 2, and it's going to go from 3 to 5. That's 2 spaces. On the picture, it would look like this. This part right here is 2 spaces. This part down here is 2. Sometimes people get confused and they start to put 5, but we're only doing the area of this rectangle. So 1.5 times 1 plus 2 times 2. When I go to do the next one, I see, okay, I'm going to have 2 down here, and then my height is 6. So this will be 2 times 6. And the last one is going to be 3 multiplied by 11. You also look at it on the table. There's 3 spaces, there's my 11, plus 3 times 11. Okay. Now, this is the first point. Okay, I have my integral, and all I'm left with is addition, subtraction, multiplication, division. I'm good there. You can leave it. Now, for purposes of the context, you might want to simplify. However, you could just write this all out again. When I crunched it, I got 38.5. I might get an email later telling me that's wrong. Now for units, where are my units notes? Remember in part A when I was saying, okay, we take the derivative of meters, we would get meters per year. Well, when I take the integral of meters per year, I get meters. So this is 38.5 meters. Okay. Integrals, let me give you guys another group. And the integral means area, we talked about in a second. It also means total. So when I go to do the context, here's my context. I'm going to say on the interval, from 2 to 10, so 2 is less than or equal to t, which is less than or equal to 10, the tree grew a total of 38.5 meters. And that would be my sample. All right, now let's talk about part D. Part D is asking if my answer in part C is an under or over estimate. Okay? Under or over estimate. And I'm going to go back to the quick drawing I made over here. I can see, all I know about my function is it goes through these points. All right? And you can see that we found the area of this part. All of these boxes. But I'm going to highlight this part in red. Those are all the parts that we left out. So for part D, I would say my answer in part C is an underestimate. And I have to justify this, okay? Because I used a left Riemann sum, and h of t is increasing. okay? You have to have both left or right and increasing or decreasing, okay? Because, and this is just an example, let's say I had a function that was decreasing. Now, if I were to use a left Riemann sum, I would overestimate. Okay? If my function was decreasing and I used a right Riemann sum, so now I go to the right side. Oops, it would help if I drew the function in first. Now, if I used a right Riemann sum as opposed to a left, it would be an underestimate. So you have to take into consideration all of those things. Okay, almost done. All right, team, moving on to part E. Part E is asking about the diameter of the trunk, and it gives you another function, g of t. And it wants to know the rate at which the diameter is changing, rate that the diameter is changing when t equals 2. So that's how I know when it says a rate is changing, that's how I know that I need to find the derivative of g. Okay. G of t is quotient rule. That's something over something. I'll give you a quick quotient rule review. Q-U-O. Might not be how you spell quotient. So if I have a function, f of x is equal to g of x over h of x, then when I take the derivative, I would do bottom or low derivative high, so h of x times g prime of x, minus, it's different from product rule, high derivative low, so that would be g of x times h prime of x, and then all over low squared, so it's h of x squared. Okay. So when I go to do the derivative here, I'll say, okay, g prime of t is equal to low derivative high, so I keep this as 5t, and now I'm doing the derivative of e to the t. Good news for us, that's just e to the power of t, minus high, e t, derivative low, so that would just be 5, okay, all over 5t squared. Make sure you put brackets here. I could see somebody going, oh, 5t squared, which is not the same. This is going to turn out to be 25t, so be careful. All right, this is our first point, just doing the derivative. Second point is going to be to do g prime of 2. All right, well, that's no problem. I'll just plug in 2. So 5 times 2 times e squared minus e squared times 5 all over 5 times 2 squared. Now, when you get here, it's very important. Just stop. You got the point for g prime of 2. That is all the same. If you want to simplify it, you certainly can. I would get 10e squared minus 5e squared all over 100. And you could say, oh, Mr. Laughlin, can't I just make this 5e squared over 100? I mean, you guys certainly can, which would give you what? E squared over 20. And if you even wanted to put that into your calculator, you could. But why? This is totally correct. Stop here. Okay, guys, you got a couple of these to do for homework. I know this one was a little bit longer. I appreciate all of you guys who are sending me feedback on these, and I'll see you again soon.